Assalamualaikum, one and all. It's my pleasure to have you back to Sir K Lab's physics and chemistry tutorials for high school students. In this episode, we go back to a basic concept in chemistry, the mole concept. How well have you understood the meaning of a mole? We'll find that out. Just hang on, watch and learn. Questions 1 and 2 are check your understanding questions. Just write the missing word or number in each blank, letter A to letter G. Question number 1. 1 mole of water, H2O, is equal to A, uh, H2O molecules. In 1 mole of H2O molecules, there is a total of, letter B, blank atoms. 1 mole of water contains, letter C, blank hydrogen atoms, and letter D, blank oxygen atoms. Number 2, if 1 mole of table sugar or sucrose C12H22O11 molecules were separated into atoms of various elements, there would be, letter E, blank moles of carbon atoms, letter F, blank moles of hydrogen atoms, and letter G, blank moles of oxygen atoms. Question number 3. Compare 1 mole of hydrogen gas, 1 mole of oxygen gas, and 1 mole of fluorine gas. Question letter A. Which has the largest number of molecules? Letter B. Which has the greatest mass? For both questions, A and B, you have to explain your answers. And question number 4. The Cullinan diamond was the largest natural diamond ever found in January 26, 1905. It weighed 3,106 carats, where 1 carat is equal to 200 milligrams. Question is, how many carbon atoms were present in the stone? Here are the answers to questions 1 and 2. For question number 1, 1 mole of water, H2O, is equal to, letter A, blank H2O molecules. So the correct answer is 6.02 times 10 to the 23rd power water molecules. In 1 mole of water molecules, there is a total of, letter B, blank atoms. The correct answer is 18.06 times 10 to the 23rd power atoms. Because as the formula for water suggests, all right, H2O, so there's a total of 3 atoms, all right, H2O, 2 hydrogen and 1 oxygen atom, they comprise 1 mole of molecules. But what we are asked is the actual number of hydrogen and oxygen atoms in 1 mole. So, since there are three, all right, there are three types of atoms, we just multiply Avogadro's number, all right, 6.02 times 10 to the 23rd power times 3, and that gives us 18.06 times 10 to the 23rd number of atoms, right? 1 mole of water contains, letter C, blank hydrogen atoms. So, since there are 2 hydrogen atoms, the Avogadro's number is also multiplied by 2, and that gives us 12.04 times 10 to the 23rd power hydrogen atoms. And letter D, there are 6.02 times 10 to the 23rd oxygen atoms, because there is only one oxygen atom in 1 mole of water molecules. So that's just exactly equal to the Avogadro's number, 6.02 times 10 to the 23rd oxygen atoms. And moving on to question number 2, here are the answers. If 1 mole of sucrose C12H22O11 molecules were separated into atoms of various elements, there would be, for letter E, there will be 12 moles of carbon atoms, right? So in this formula for sucrose, which is exactly 1 mole of sucrose molecules, the subscript for each atom, say for example, the subscript 12, can also be interpreted to mean that there are 12 moles of carbon atoms. And for letter F, referring to the number of moles of the hydrogen atom, since the subscript for hydrogen is 22, it means that we are talking about 22 moles of hydrogen atoms. And lastly, for letter G, all right, the answer is there are 11 moles of oxygen atoms, because the subscript of oxygen in this sucrose molecules, or 1 mole of sucrose molecules, all right, this simply means that there are 11 moles of oxygen atoms. For question number 3, we are given 1 mole of each of the gases: hydrogen, or H2, oxygen, O2, and fluorine, F2. Notice that these gases are all diatomic gases. And we are asked to find, for letter A, which gas, or which among the 3 gases, has the largest number of molecules. And for question letter B, which among the 3 gases has the greatest mass, right? Like mass in grams. All right. So our answer to question number 3, letter A, we say that all of the 3 gases have the same number of molecules, all right, equal to the Avogadro's number, 6.02 times 10 to the 23rd power, okay, molecules. That is the definition of 1 mole. Since all the three gases have the same number of moles, that is 1 mole of each of these three gases, right? So it simply means that each one of them has the same number of molecules, exactly equal to the Avogadro's number. To compute the mass equivalent of each mole of the gas, we use the formula, all right? So the formula means that the mass in grams of the substance is equal to the given number of moles times the molar mass of the substance expressed in grams per mole, right? So for 1 mole of hydrogen gas, H2 gas, that is, right? So we determine its mass by just multiplying 1 mole of H2 or hydrogen gas by the molar mass of H2 or hydrogen gas, which is 2.00 grams per mole. And we will get M equals 2.00 grams of hydrogen gas. Also, for the oxygen O2 gas, all right, we multiply 1 mole of oxygen or O2 gas by its molar mass, which is 32.0 grams per mole. Why 32.0 grams? Because one oxygen atom has an atomic mass of 16.0 grams per mole, or to be strict about it, 16.0 atomic mass unit. We call that the atomic mass of the oxygen element or atom. Since the oxygen gas O2 is diatomic, we multiply 16.0 grams per mole by 2. That's how we got 32.0 grams per mole. That means the mass equivalent of oxygen gas is 32.0 grams. And lastly, for the mass of the fluorine gas F2, right? We multiply 1 mole of F2 gas by 38.0 grams per mole. We got 38.0 grams per mole by multiplying the atomic mass of the fluorine element, which is 19.0 atomic mass unit. All right? So 19.0 atomic mass unit multiplied by 2 will give us 38.0 atomic mass unit. All right? But when converted to its what we call molar mass, we just replace the atomic mass unit by the unit grams per mole. In short, the mass equivalent for fluorine gas F2 is 38.0 grams of the fluorine gas. So therefore, our final answer, right, to this question, which among the three gases has the greatest mass? Our answer is, of course, F2 or fluorine gas has the greatest mass. Finally, we have the solution to question number 4. All right. So in question number 4, we are given the mass of the diamond stone, okay, equal to 3,106 carats. Given that 1 carat is equivalent to 200 milligrams, we find that 3,106 carats has an equivalent mass equal to 621.2 grams. And we are asked to find the number of carbon atoms present in the Callahan diamond stone. All right? So we denote that by capital N. The number of carbon atoms. We know that diamond is an allotrope or an elemental form of carbon. And we can find the number of carbon atoms, capital N, by using this formula. All right? Starting with the given mass of carbon atoms in grams, we divide it by the molar mass of carbon in grams per mole. All right? So that will be multiplied by the Avogadro's number. And we end up getting the number of carbon atoms. So following this formula, we find the number of carbon atoms, capital N, equals 621.2 grams, okay, divided by the molar mass of carbon, carbon 12 that is, which is 12.00 grams per mole in 4 significant figures. So the unit grams cancels, all right, and then the result will be multiplied by Avogadro's number. We use the Avogadro's number with 4 significant figures, 6.022 raised to the 23rd power atoms per mole, right? So the unit mole also cancels out, and we are left with the number of carbon atoms equal to 3.116 times 10 to the 25th power carbon atoms. So that's it. We are done. Till the next episode. Mabuhay. MashaAllah. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.